In this video, I'd like to show an enhancement to Illuminated Cloud's Unresolvable Declaration code inspection. The Unresolvable Declaration code inspection has been a feature of Illuminated Cloud since the release of Illuminated Cloud 2, and it's one of the real-time static code analysis capabilities, in this case, that finds references to identifiers, whether they're classes or methods or constructors or variables or whatever, that it can't resolve, that it can't find the actual declaration or implementation of that. This can take one of two forms. The most common is that you have a typo, you've misspelled the name of something. With things like code completion, that should become less of an issue, but it happens. But the other way that it can manifest is that you actually start to write out the code, the expressions that represent the behavior that you want, and then you fill in the details behind the scene. This is actually a key tenet of test-driven development, where you actually write a test for something that doesn't exist yet, and then you kind of incrementally begin building that out to support and to pass the test. It's actually a really nice way of building out logic that you haven't implemented yet. And that's actually what I'm going to demonstrate here. So in this case, all of this red represents symbols that do not yet exist. I have added something called a code intention, which is effectively a quick fix to this particular inspection that allows Illuminated Cloud to help you to create the missing or unresolvable declarations. There are other code inspections that have these types of quick fixes. For example, the unused declaration code inspection has always had one that is remove the unused declaration, clean up the code that you no longer need. Well, in this case, the code inspections, and I believe that probably the best way to explain this further is by example. So we'll just go ahead and walk through this. In this case, the code intentions, the quick fixes, have Illuminated Cloud actually offer to help you stub out or create the unresolvable declarations. So in this case, it has realized that this must be a type because of the fact that it's being used as a type for a variable declaration. And that's something that's very important. Illuminated Cloud is going to gather all the context it can about the missing declaration and offer to create the types of declarations that make sense. In this case, types, but we'll see others as we walk through this. So this can be either a top-level class, enum, inner class, a top-level interface, inner enum, inner interface. So what we'll do is just, for the sake of initial example, create these as inner classes. We'll create some top-level classes momentarily. So I'm just going to say create an inner class called app session in the current top-level class, create unresolvable declaration test. So I'm going to hit enter, and it actually goes out and creates that. And it creates it using a template. So now it's going to allow me to choose the visibility of the new class. It's going to allow me to choose the sharing model. You'll note that there's no option to forgo a sharing model. Certainly that is possible in Apex. It is not considered a best practice. It's actually a source of many bugs, is not having an explicit sharing model. So this particular mechanism in Illuminated Cloud is going to force you to choose one of the declarative sharing models, with sharing, without sharing, or an inherited sharing, with the default being with sharing. And then you're in the body of the actual class to begin implementing if you want. So we're not going to implement right now. We're just going to walk through and stub out everything that we need to support this particular set of code. So it looks like we need to actually create a constructor, but to create a constructor, we need to be able to create a class. This is going to be a builder pattern. We can see that here. So it's going to create a builder. It's going to set some parameters of the builder, and then it's going to create an instance of an app session. So I'll go ahead and create another inner class called Session Builder. Gets created right after the last one, so it's actually the last declaration that's inserted. Again, it's going to take us to the template, and we have that. Now we could go ahead and create the method with session type, but this will give me a great opportunity to show what I mean when I say Illuminated Cloud is going to use all the context available to it to create the most accurate declaration that it can. If I create with session type right now, it knows that it needs to create that inside of Session Builder, so it will do that. Notice that the parameter type is object, because the parameter passed to it is unresolvable, so it knows nothing about it. The best it can offer is object. Let's see if we can make that a little bit better by doing things in an order that provides more context. So this is going to be an enum with an enum constant. So let's create an inner enum called session type. That's fine. We'll go ahead and create the enum constant for it. short-lived. And now we'll go back over and create session type again. And you'll notice that now the parameter is called session type, and it's already offered with the variable name of session type. Because it's a builder pattern, it offered a return type name of app session because that's what the whole expression is assigned to. But because it's a builder pattern, we know that it should actually return a session builder. Okay, and now we've actually created that builder method, and now we'll create the second method, create, and that should in fact create an app session. And now our builder is at least in a skeletal form. So going to the next one, it's saying that the app session class should have a method called getSession. Because this is being assigned on the left-hand side to something of type string, it automatically creates a return type of string. And you'll notice that it adds a return statement to it because it's not a void method. If this were a void method, and we'll see this shortly, it would not add a return statement as part of the template of the new class. Okay. So the next thing that we'll do is we'll actually stub out the next missing class. In this case, I'll do it as a top-level class, and it's going to use the file template-based mechanism in order to create that. So it created this class just as if you said file new Apex class. And now we'll go over and create another class at the top level, user manager. Created that at the top level. And now we'll add a method to user manager, and this is being called as a static method, as a class method, because it's not being called on an instance, and Illuminated Cloud will infer that. So it'll infer a lot of things. Let's take a look. It will infer that it needs to return auth user because the actual invocation is being assigned on the left-hand side to auth user. It will infer that it takes one parameter of type string, and it'll even offer parameter name suggestions based upon the invocation expression, so username. So now we have our static method that returns auth user, takes one parameter called username, and that's now resolvable. Once again, if I were to try to create a login method here, it would not know what to do with the second and third parameters. They're both object because it's using unresolved information. So again, order does matter. We'll go ahead and create a method called getUsername. There's no context to know what getUsername should return, so we'll just go ahead and say string. We'll go back over, and then because of the casing of this, it will know that this is potentially a constant field, a static final. Now it'll also offer to make it a field or a property or a local variable here on the actual local stack of this particular method invocation, but we'll go ahead and say constant field. And so we've got private static final, and we'll go ahead and call this an integer, and we'll give it a default value of 10,000. Okay, we'll go ahead and say that. So now we can actually build out our login method. And now it gets everything right. It's an instance method with a parameter of string. We can call it session ID, another parameter of string we can call username, and a parameter of integer that we can call session timeout. And now nothing is read. I built out the skeleton without actually having to really write any code. I let Illuminated Cloud do it for me by me sketching out what it is I wanted to do. So this is available starting with 2.1.0.1. The one thing that's missing from it right now is the ability to have it stub out a method or constructor formal parameter. That will be coming, but there's some infrastructure required to do that. It's the same infrastructure required for the change method signature and extract parameter, introduce parameter refactorings. And so I'll be doing all that work together, hopefully next for the next release or one of the very near-term releases. I hope you find this feature useful, and certainly let me know if you find any bugs. And thank you very much for your time.